Well, good afternoon and welcome everyone to this webinar on embracing flexibility to reduce business energy costs. I'm your host this afternoon. My name is Jared Leake, the CEO for the Australian Alliance for Energy Productivity. And I'd like to commence this webinar by acknowledging the traditional custodians of country throughout Australia and their connections to land, sea and community, and pay my respects to their futures for past, present and into the future. For those that are new to A2EP, we are a member-funded non-for-profit organisation, and this is our amazing set of members here. And they share our vision of improving Australia's energy productivity and using that to decarbonise. And without the support of these fabulous members, we would not be able to bring you all these insights and webinars that we do. A little bit of housekeeping for today. The presentations will be sent out to you next week for those that have registered, and along with a recording as well. We're certainly hoping to take questions today, so get ready to pop that question in the Q&A box down the bottom and upvote anyone else's question with the thumbs up that you like. If not, you can use the chat for a bit of a sidebar discussion, whatever suits your liking. Joining me here today from the A2EP team, I've got Brendan Voss. He's our research project manager doing some really exciting stuff on decarbonising heat. Brendan, welcome to you today. We look forward to utilising your many years of knowledge and experience when it comes to chillers, and one of the most likely and biggest targets for going after energy flexibility. So welcome, Brendan. Look forward to you helping and manning the questions and coming forth with some questions for the panel here today. Load flexing, embracing flexibility, certainly not a new topic for A2EP. We've been working on this for many years, and there's just a couple of the studies we've done over the last few years. The REALM study, one on the left, renewable energy and load management, that was one of the earlier ones looking at load flex. And since then, we've gone on to do several studies with the Race for 2030 CRC, with opportunity assessment, looking at the overall potential for load flex and opportunity and what have you, and then more of a specific study with abattoirs. But certainly, if Australia is going to meet its targets of 82% renewables and 34% emission reduction by 2030, load flexing and is going to have to be a big part of that. Otherwise, we're looking at paying for a lot for dispatchable energy. If not, we're going to be keeping on fossil fuel diesel and gas-fired power stations for a lot longer. So with that, we've got the targets in place. There's some research there. It's been fabulous now to see how this is really hitting the ground, and we're seeing so many examples come forward of how energy flexibility is really paying off. And to set the scene today, to give us a feel for really what's going on here in this space, we've got Jasper Noort, who's going to kick us off today, followed by Paul Moore from VIOTAS. Introduction for Paul a little bit later. But Jasper, I'd like to welcome Jasper here. Jasper is the Associate Director of Energy Markets team in Schneider, and he spent nearly 15 years forecasting Australian energy markets and working with hedges and what have you. And so we couldn't think of anyone better than Jasper to kick us off and give us a flavour for what's happening in the energy markets and the opportunities out there and the complexity. Jasper, I know you've prepared a presentation to take us through the what's going on. If I'll get you to share your screen and run us through the insights that you have in this market.
Thanks, Jared.
Got him.
Thanks, everyone. So I'll focus on the value of flexibility, basically to outline how that value is going to give you the potential to reduce your energy costs. And to start off with that, I will basically outline the various value sources, because it's not a single a single source of value that comes from flexibility. There's many ways to create that value from flexibility, and each way has its own characteristics and requirements, both from operational value and organizational perspective. It's important to weigh up those characteristics and how they suit your process, the technology available, and your business. And in addition, some value sources can be stacked while others are mutually exclusive. So as an example, if you have committed your demand response to a demand response service provider, you can't then also bid that same capacity into the RERT that's run by AEMO, because they kind of do the same thing. So if you've already committed that demand response capability, you can't then use it again. On the other hand, you can combine a load shifting program with a demand response program, where a daily program of load shifting can be overlaid with a response to high prices. So just running through those value sources, FCAS, or frequency control services, basically help AEMO manage the frequency of the grid. There is load shifting and peak shaving, which basically shifts your consumption to a cheaper time of the day. There's demand response, where you bid your capacity into various schemes or reduce your demand when prices are extremely high. The Reliability and Emergency Reserve Trader is a program run by AEMO, where they basically get people to bid in the price they need to reduce their consumption, which can actually be higher than the maximum price on the spot market. And basically then they tell you when to turn off, which can be a lot more manual than some of the other ways. And then finally, there is network or network support, where either you respond to a peak demand charge, or you actually have a contract with a network to more regularly reduce your demand when the network requires it. So with the rise of renewable energy, that is becoming a key driver for the need for flexibility, and one of the key drivers of the value of flexibility. With the renewable energy transition rapidly gathering pace in the next few years, we're starting to see increasing amounts of renewable energy into the grid, and to manage the highs and lows in output of that renewable energy, we're likely to see highs and lows of energy prices, and therefore we're starting to see more and more value in flexing, in being able to shift your consumption across the day and across multiple days, as you can see there in the modeling or the chart that's from our modeling, where we project the amount of generation from various sources into the future. So another driver of the value of flexibility is regulatory changes. I think I'm stuck on the same slide, I know.
We got you.
Jared, can you just confirm for me that I'm actually showing
slide 4? We can see slide 4, Jasper.
Okay, thanks. That's good, because my other screen is not showing that. Anyway, so yes, another driver of the value of flexibility is changing market rules. Recently, the very fast FCAS market went live, or fast frequency response. which basically rewards a quicker response to changes in frequency. And especially some of the loads can actually be quite are quite compatible with that service. So loads that are actually quite able to change rapidly or quite easily controlled, and can therefore actually be rewarded for the faster response that they can provide compared to a more traditional generator. Obviously, they'll have to compete with batteries, but that's a key driver for value in the FCAS market. However, more recently, on the more traditional markets, the AEMC has confirmed its final determination for the market price cap, which will now rapidly increase over the next few years to nearly 28,000 by our projections by 2028. So that's from July 2027. So in the chart there, I've shown basically Victorian energy prices on 13 February this year, when the Loy Yang power station shut down after a transmission issue where towers fell over somewhere else in Victoria. And as a result, we had prices at the market price cap for nearly 2 hours. So a 1 megawatt capacity of demand response during those 2 hours would have received around $33,000 basically this year. However, by 2028, they would receive nearly $55,000. So there's a clear change in the value of flexibility over that time frame, and it might mean that a process that is currently doesn't necessarily make sense, or is hard to recover the value of, or the investment might not justify it currently. In a few years' time, it may be much more attractive to provide that demand response. And finally, basically another driver from the changing market rules, and a reason why the market rules to some extent are changing as well, is that we're seeing more generation basically contracted. So the renewable generation is contracted to PPAs, which means that some of the renewable generators are not quite as responsive to market prices, depending on the terms of those PPAs. However, for an energy consumer, it's quite important to make sure that prices that you consume when prices are low, because that reduces the cost of firming that renewable generation around it. Because obviously, the more we rely on generators, the higher the overall price will be. Because when we use generators for very small amounts of time, basically they need to be paid enough to be in the grid. And if we can reduce that amount of generation that's required, it will really help to keep overall costs down. So this chart here shows how prices have changed with the transition that's been happening over the last few years. So we're comparing prices at a half-hourly level in 2020 across a day, on average across the year, with the same price profile for 2023. And what you can see is that the value that are in the middle of the day is actually turned negative in some states, whereas the evening peak prices have soared. And it's really giving a clear sense of how flexibility would give you a lot more value in 2023 compared to 2020. And with the transition that we're in, we're likely to see that continue, and therefore, and especially with the change in the market price cap, that evening peak on average may actually increase further. So then moving on to how to implement that flexibility. So when you're thinking about the flexibility, it's really important to think about what is the value, what is required to implement the value source that you're looking to do. How does it work? For each value source, there's very different ways it can work. For instance, for FCAS, you need an automated system. It's too quick to have somebody go for a button. Whereas on the other hand, for RERT, you can actually kind of get a signal and have enough time to turn it down less or in a less automated way. Another key question that you need to think about is what organizational support is required. Especially depending on your process, you will have to make sure that the people that run that process are actually comfortable with what you're doing. So, for instance, if you need to turn on an emergency generator, is that going to create a problem because there is a switchover from grid to emergency power? And can the processes that you're running internally actually cope with that switchover? Or are you going to be in the dark for some period of time because some lights need time to warm up? So it's clear that there is a lot of things to think about. So there's some examples that are good resources for load shifting. There's microgrids. There's heat and cold storage that can provide opportunities. Hot water systems are a very good thing that can be used. Obviously, pumping loads and batteries, depending on the flexibility around the pumping load. So then, in particular, on how to extract the value, there is demand response programs run by retailers, but there's also demand response providers. Many retailers these days are running virtual power plants that you can subscribe to. You can actually have spot exposure in your retail contract. And then finally, one of the less efficient ways is to actually change your load that you submit to your retailer as part of your retail contract. And that might create or reflect some value if you change your consumption in a certain way to lower cost periods. Retailers will value that as part of the retail contract. However, when you go on, when you implement a program like that, it is very important to thoroughly analyze all the implication, risks, values, but also when you enter into a contract with a service provider, you need to carefully consider how the value is shared, but also what obligations you are taking on. Because depending on the kind of program you're going on, there will be obligations and you may be required to compensate someone if you don't follow through on that commitment. So finally, I will discuss a few practical things or case studies and talk a little bit about some practical stuff that we've done. It is important to consider that past prices are not always an accurate reflection of future prices. We've had a few years with substantial periods of high prices. In early 2020, we had some periods of very high prices, and obviously during the winter of 2022. And those periods may not be replicated in the future. So it's very important when considering whether an investment is appropriate to consider whether, how likely it is that those things will happen again in the future. And also you don't want to overpromise internally what kind of value your program is going to create. So to help with that, we use our own proprietary forecast to help people value their demand response capability or the value of shifting their energy consumption. And that can then help to support a business case or stakeholder buy-in. So with those, so one of the things we have done in the past is, and that we're actually doing currently, is support a large manufacturing business who actually has the option to decide quarterly whether they want to be on a load following or a non-load following retail contract. And as part of that, if they're non-load following, they can actually use their DR and take profit from that. On the other hand, when they do that, they're more exposed to the spot market. And we basically help them weigh that up on a quarterly basis. One of the concerns with that, obviously, is how volatile is it, and do they actually have the capability to respond to the amount of volatility that is expected. And with our forecast, we help them get their head around that. So similarly, we have helped a customer value or quantify the value and risk around their demand response capability. Basically, that's helped them develop a business case that they are now considering what they actually need to do to further develop that demand response capability. Finally, although this is not all the projects that we've done, but yes, but another final example is that we've helped someone with an electrification program to basically value how managing or using the storage within that program could help them, or a storage option in that program, how that could help them reduce their energy cost. So thank you for your attention.
Thank you, Jasper. Thank you so much. And if anyone's got a question for Jasper, please pop that in there. I might kick off with one. I'll get you to stop sharing there, Jasper. Well, I saw you had $400 per megawatt hour, that evening peak for 2023, and you think that evening peak is going to get more, Jasper. I thought with these VIOTAS super batteries and things coming in, maybe that's going to alleviate a bit of that cost in the peak in the evening. You sort of still think this is going to continue on?
Well, I mean, on the other hand, we've got Araring coming out as well. There we go. I think you've stopped my share screen.
I have.
Thank you. Because yes, I was kind of stuck in there. Anyway, we've got Araring coming out. We've got other dispatchable generation coming out. So regardless, I think there will be times with more volatility. I mean, just today or yesterday, we had volatility in Queensland with prices spiking. So there will be more challenges here and there, basically where we have periods of high and low renewable output, along with tightness in the grid. We've been, just the last 6 months, supply has been pretty good, where all the coal-fired generation has been running very consistently, and that's created some low prices. but basically with fewer coal-fired generators in the grid, we will get more challenges from time to time when things are tight, like in 2022, and also things like the VIOTAS battery. Most of the batteries are still relatively short duration, so I do think that there will be events, and you can't always accurately forecast, and that's why we use a range of outcomes, because basically this year we've got an El Nino, and in Victoria it's actually not been as hot as expected. On the other hand, in Queensland it's been very warm, but next year there is some suggestions we might go back to La Nina. So you just you can't expect that same outcome to happen every year, and that's why it's good to have a range of outcomes that you're considering, both from the upper end of the risk as well as the lower end, so that you don't have unrealistic expectations about the value that you might create.
Gotcha. Brendan, we've got a few questions coming in.
Sure. Now we have one. It's quite a simple one. It says that the RERT program seems to be quite an unreliable income stream. Just after Jasper's opinion on that one.
I think, look, the RERT program, the key thing about the RERT program is that you don't have a lot of control yourself. You're basically sitting there waiting for a call from AEMO, and it doesn't happen every year. So if you want to get value out of your flexibility, it's good if you basically have some capacity that you're happy to provide, but you're not that keen to use all the time. But yeah, basically if you want regular value, there's probably other options that are going to provide you a better or a more consistent return.
Sure. There's one more question here on 2 hours out from the event. Looking at forward prices, how likely is it those prices would actually be realized? So, like, as in, like, I guess that's a very broad question, but yeah, at a high level, like, how often does it hit the actual price? So
it varies a lot. So obviously, like a great example is the Loy Yang outage, where basically there was no notice at all. Basically, it happened, and 2 hours after that event, the prices were at the maximum, at the price cap of 16,600. Other days, like yesterday, I think there was actually high prices forecast, but they didn't happen exactly as forecast. And a key reason for that is that generators change their bidding all the time. And basically, depending on their contract position and their exposure to the spot market, they may change their bidding to either increase the impact of high prices or actually basically push the high prices out of the market because they're actually exposed to the spot price. And basically, you just got to be flexible enough and not always expect it to happen. Now, I know that, for some businesses that can be quite difficult, but that's basically where ongoing advice or I suppose a partnership with a with a service provider can help you be either educated or basically take some of that burden out of your hand, where people are actually monitoring the market all the time, and are basically giving you good advice about how likely it is and whether you should be ready to act.
Thanks for that, Jasper and Brendan. And there's a few questions there. Feel free to type some answers in there, and if not, we'll try and get back to them at the end of the webinar. But we might move on now And I'm picking up now on what you said there, Jasper. You said that compared to RERT, there might be some other more reliable income streams. What a great segue. Thank you, Jasper, to start talking more about FCAS directly. And that's why we do have Paul Moore here. He's the Managing Director for VIOTAS Australia. And that's VIOTAS is a leading demand response aggregator who specialises in contingency FCAS services. Paul himself, 20 years experience in the industrial automation and power systems market, both in Ireland and here. And he's currently competing, finishing his PhD. So soon enough will be Dr. Moore, but for now we'll go with Paul. Paul, take us through it. It'd be great for you to share your screen. Take us through the presentation that you have that's going to take us through FCAS and the opportunity there. I think it looks much more reliable and certain than RERT, but you tell us.
Sure, thanks, Jared. Can you just confirm, first of all, that I've got that shared?
Not yet. No, that hasn't come up for us. It's on its way now, though.
Now, yeah, we're all good.
Yep, we're in business. Over to you.
Cool, thanks for that intro, Jared. Yeah, so my name's Paul Moore. I'm with VIOTAS, and as Jared says, we're a demand response aggregator. So I'm here today to talk to you a little bit about how you can get paid by participating in the market while supporting the net zero transition. So that's the theme of the talk today. The things that I'm going to cover is I'm going to cover some of the common demand response. I'd call them myths now because a lot of them are sort of old adages that I think are no longer true. So I'll cover off some of those, take you through the specifics of what's involved in FCAS and particularly the specifics of what's involved with a demand site participating in the FCAS markets. We'll go through a little bit of the characteristics of FCAS itself and what the monetary values might look like. And I'll also take a bit of a forward-looking view of where we see the FCAS markets. And so like Jasper put a disclaimer on that our forward-looking view is our opinion and partially based on past performance. So it's certainly by no means to be considered a forecast, but we'll give you what my opinion is. And yeah, hopefully leave it open for plenty of Q&A at the end. So I'll jump straight into it. So just first of all, a couple of definitions. Jasper covered very well in his presentation. Demand response is quite a broad term. And FCAS is really a subset of demand response. So demand response is any time an electricity consumer or a customer changes their consumption profile in response, normally to a price signal of some description. FCAS is very much a specific subset of the demand response suite. And so, look, these are some of and I call them myths because I think over the course of the presentation, hopefully I'll dispel some of them. But some of the things that we commonly hear from customers is that the requirement of demand response, the duration is simply too long for the plant or the operation to tolerate. It's oftentimes considered a bit complex and risky to participate in. With regard to markets like FCAS, I've heard comments that it's not yet proven. A lot of people do consider that the FCAS markets are what big batteries do and what generators do. And we oftentimes hear stories of how demand response is going to cause disruption in the plant and potentially even equipment failures. So over the course of this presentation, I hope to address those concerns. So I'll jump right into it. What exactly is FCAS? We oftentimes hear FCAS referred to in very broad terms, and people make sweeping generalizations about it. But I did want to try and break it down a little bit for the audience here, so we've a bit of clarity. Today, I'm talking specifically about contingency FCAS. So the FCAS market is divided broadly into two categories, contingency FCAS and regulation FCAS. So the characteristics of both. Contingency FCAS is used by AEMO when something has gone wrong in the grid. So it's when a large generator is tripped or transmission tower or something has gone over, causing a lack of generation in the grid. It's been open to demand side participation since 2017. So it's actually quite a well-established demand response market to participate in. And one of the key characteristics of contingency FCAS is suppliers are paid based on availability. It is not a dispatch-based market like what traditional demand response markets might be. So the suppliers do get paid continually, regardless of whether there's been an event or not. On the other hand, regulation FCAS is a little bit different. Regulation FCAS is more the remit of generators. I would call it the cruise control for grid frequency. Some power systems engineers might question me on that, but it behaves essentially like cruise control. The speed of the grid, and I'm from a power systems background, the speed of a grid is 50 hertz. It's related to the speed of rotating mass, so it is directly correlated with speed. We try and keep it around 50 hertz. Minor fluctuations in load will cause that to move up and down, and that's what regulation FCAS does. And just for clarity's sake, we're not discussing regulation FCAS today. So I did think it's worth just making those clarifications, because the characteristics and pricing and so forth, it really does depend on which specific FCAS market are you actually talking about here. And so just to reconfirm for people who may not be fully across it, how does contingency FCAS actually work on the demand side? So I've got a little bit of an oversimplified graphic here on the right-hand side, where we have the unexpected loss of a large power generator, and it might be a transmission tower. We saw that on the 13th of February. It was actually the transmission going over that caused the generator to trip, so it's sort of the other way around. Either way, you get a massive imbalance in the grid. And so AEMO always need to have that contingency covered with spinning reserve, or what's the equivalent of spinning reserve. And so there's two mechanisms there. You can either rapidly increase generation output to make up for the loss, or you can rapidly deload the grid as well, which is essentially what the demand side is doing. You rapidly drop 3 megawatts of a cement mill, for example, and it's the same as if you ramped a generator by 3 megawatts. There's the same net effect on the grid. And so that's how demand response in contingency FCAS in effect works. I thought I might clarify what the role of an aggregator or a demand response service provider like ourselves is. This isn't a promotion of VIOTAS by any stretch. This is the same with any aggregator that's out there in the market. So what exactly do they do? An aggregator, typically for a demand site, an industrial or a large commercial customer, will have a piece of hardware that's monitoring grid frequency. And it's usually a relatively specialized piece of frequency monitoring kit. It's not your typical power meter, and there are some special characteristics you need for FCAS. And it is listening to the grid frequency at all times, because as Jasper said, this is not something that you pick up the phone and ask someone to do. This is an automated response. And so you have to be monitoring the grid frequency in real time. And you need to be able to accurately determine whether it actually is a grid frequency event or whether it's some other transient that might be happening on the grid, because the last thing you want is to be tripping customers out on a transient type event. So that asset will normally send then a dispatch command to whatever the particular load at the site happens to be. And bearing in mind these days, it might actually be behind the meter generation, because ramping up behind the meter generation is the same thing as reducing the load. It's whatever the net that's seen at the NIMI is what the actual response is. So typically it might be cement mills, it might be emergency backup systems in data centers, so online UPSs and so forth. Cold storage is a great one, and I know we've got Brendan online here, so I'm sure he'll talk a little bit about chillers and their response later on. And finally, the last function that the aggregator does is the aggregator takes on all the risk around the market compliance piece. So the demand site or the customer does not have any of that market participation risk. That's the job of the aggregator to do. And the complete financial settlement portion as well. So the bidding of the available assets, the enablement, and the follow through to final financial settlement and actual payment. So a company like ours will issue RCTIs to customers for full clearance of the money as well. So that's in essence the role that an aggregator plays in the whole thing. I wanted to cover a little bit around the FCAS key characteristics, and this is what I think will change people's minds around whether their site is suitable for demand response. And I think some of these characteristics, particularly since the introduction of the very fast R1 market, which Jasper mentioned in his presentation as well, really does change, I hope, the way people view demand response. We're going to have a look at the prices later on, but I can confirm the bulk of FCAS revenue now does sit in the R1 market. AEMO is after faster and faster responses. As we move towards a more lower inertia-based grid, this service gets valued more, and the value dwindles in the slower services. Now, the reason that's relevant for a demand type site is it would actually be a valid trading strategy if you had a load that was capable of the 1 second response, and we'll go into that in a second. Your maximum response duration is actually only 6 seconds to access the revenue in that market. And that very much fundamentally changes how you would look at the disruption on a plant, because all of a sudden you're not talking about hours in the afternoon of an outage. You're talking a very, very short duration. And in a site process that might have a bit of inertia behind it, there may actually be no interruption to plant at all if it's done accurately. And so the other services still remain. So we've got the R6, R60, and R5. But what we will see later on is the slower markets, the value has dropped away. So what we're seeing is very much a shift of the revenue towards those faster and frankly more difficult markets to perform in. But I'll cover how we do that later on. For those of you that might be interested, the frequency of these events, so how often will they actually happen? It varies, but it's on a yearly basis, it's somewhere between 6 to 12 events over the course of the year. They're not events that can be forecasted by the very nature of them. They're contingency events. So who can tell when a transmission tower is going to actually blow over? Very difficult to forecast, but the response is automated by the metering equipment that I talked about earlier that goes on site to do that response. I should point out at this stage within our team, we all come from an engineering. I myself come from a controls background. So we're well used to getting on site and having a look at an assets control scheme and working out how we can best integrate with that and isolate specific loads. So we're not in the business of taking out a whole site. We're much more laser focused on that, where a specific subload on a site can be taken out. Particularly ones like if you think of refrigeration plant, typically the biggest portion of a refrigeration plant is going to be its compressor. We can get in there and isolate just the compressor and let it coast for a period of time while leaving the lube pumps and all the other portions of the plant online, remaining connected to the power, and just isolate that for the short duration response and then bring it back on again. And that's a very viable way of participating in this market. So I think from a VIOTAS perspective, it's an important part of the business that we do is actually understanding the customer's assets in their plant and the characteristics of them, so that we can get something that is going to function well in the market but not interrupt plant too much either. So what types of loads are typically suitable for FCAS? I've covered some of them already. So in the mining and quarrying side of things, big motors, fans, mills are particularly good. So a lot of our customer base so far has been large cement mills, typically secondary mills. So where the big rocks have already been broken down a little bit, the secondary mills can start back up under load without needing to be cleared out or anything like that. So that's, like I said, that's part of what we do, is to look into different assets and see what the actual requirements of each individual ones and which are going to be suitable for participation or not. Within data centers, it's usually the emergency backup. So data centers do not want to drop load, and that's not what we do when we look at the data centers. Data centers luckily have typically online backup systems so that if there is a grid failure, there's a bumper transfer of IT load, and we leverage that to perform in the market. Cold storage, I mentioned already. I don't want to talk too much about cold storage with an expert like Brendan on the line, because it's process plant is not my area of expertise, but I'm sure Brendan can answer anything on that. And then other types of assets, wastewater treatment, large pump sets, that sort of thing, irrigation pumps. Essentially anything that's relatively flat and predictable. If it runs to a schedule, it's automated, it can probably be considered, as opposed to anything that might be manually controlled. If it's manually controlled, it's harder to predict, it's harder to bid into the market. Unfortunately, human beings, we haven't figured out a good way of what they're going to do from 1 minute to the next still. So until that day, it's probably more your scheduled and automated assets that suit. I've got down here as well, typically assets that are greater than 500 kilowatts. That's more of an economics thing. You've got to consider the business case of you're going to have to do some testing, some installation of equipment to participate. The equipment costs money, the installation costs money, and the customer and the aggregator, the economic benefits need to be there. And currently, we've found that sits roughly around the 500 kilowatts. Anything greater than that, we can typically work with. So market trends, I did say I would look at market trends and pricing. And so what we're looking at on here is the O&S market was introduced in October 2023. The O&S market is the darker brown color that you can see on there. And the orange shades are call them the legacy markets. And so what you can see is a very sharp decline in value in what I'd call the legacy markets. They're not gone by any stretch, but they're the existing markets. But you can see the revenue is completely dominated now by the new O&S market. And so going back to what I was talking about earlier, it's a valid trading strategy for a demand side now to say, hey, I might just pop in for O&S. I know I'm going to limit my outage for a maximum of 6 seconds. And in doing that, I'm going to pick up well over 90% of the revenue. And so contrary to what people have been talking about, that batteries will push the FCAS price down, it's more that it's shifting the value. It's shifting the value into the faster markets. The more slower legacy markets, yes, the value is dropping, but the increased revenue seen from the O&S market has more than compensated for that, as you can see. So, the month of January, the average FCAS price across the 4 markets was 35 grand per megawatt hour. Or sorry, per megawatt month, I should say. Beg your pardon. These are in the unit of megawatt months. So just to kind of put some backup and proof around what I was saying earlier around demand response capabilities and ability to compete with batteries as well in the FCAS markets, I think FCAS became a common discussion point when, I guess, the Tesla battery was built in South Australia, and everyone became aware of the revenues that were involved at the time. And I think the perception that only big batteries can access that kind of revenue probably still stuck around, because those guys certainly do good marketing around what they do. What I wanted to do here is just point out 2 particular participants on this list. So there's ourselves and our friends at Enelex, both demand response participants. And you can see on this graph from Q1 2023, by volume participating in the O&S market, ourselves and Enelex did a good job of competing with the batteries in terms of the actual volumes. So that means customers of VIOTAS and customers of people like Enelex were receiving equivalent revenues to what the big batteries were actually receiving for the same period. Now, I should qualify what I'm saying here by stating that the O&S market still is in a capped condition. So it started off when it was introduced at 50 megawatts. It's now capped at 225 megawatts. The underlying demand is actually much higher than that. It's currently capped because supply is limited, and if the cap was lifted, the price would go to market cap quite quickly. And so it's still currently capped. The reason for that is demand is strong for the service, but supply is still sort of thereabouts. It's limited at the moment, as you can see from the list of participants. Big batteries and demand response with the right power metering and control capabilities are the only assets that can actually participate. You're not seeing thermal plant participate, and that's down to the mechanical limitations of the rotating equipment. They just simply can't respond quick enough to participate in the market. Now, what that means from a pricing perspective is what we've seen happen with the R1 price. In our opinion, that trend will continue, that we'll just see very high R1S prices, and probably the remainder of the markets stay quite low. But overall, the FCAS pricing will remain strong in aggregate across them. The other thing I wanted to say about big batteries is we've seen a number of comments out there that big batteries will force the FCAS price down, and that's not entirely true. That's a slight mischaracterization of the market. And I've just picked out this one example, which I quite like, and there's other things I'll talk about on this subject as well. But one of the things I wanted to point out is this is actually the bid stack. This is going back to January. This is the bid stack of everyone providing R1S. And you can see here the salmon color. That's actually Torrens Island Power Station and how they're bidding into the market and their capacity. But what you'll notice right over here, right around midnight, is the salmon disappeared from the bid stack and everything dropped down. And correspondingly, the price in the market at exactly the same time, if you see midnight right here, hopefully everyone can see my cursor on the graphic on the right, the price shot up. And so what I'm getting to here is batteries, and big batteries particularly, actually become not a contingency, but a driver of high prices. So if a battery has to pull out of the market, and there can be many reasons why they would do that. One of the ones that springs to mind is the spread opportunities that Jasper had on his chart. Those spreads opportunities for battery are increasing rapidly. If I saw a spread opportunity like that coming up and I was operating a battery, I would pull all my capacity from FCAS and I'd put it into energy because we can't have the same megawatt in multiple markets. You just can't do that. And so a megawatt in FCAS is not a megawatt in energy, for example. But also there can be maintenance issues. There can be all sorts of reasons why a battery might come offline and cause this effect in the pricing as well. So I thought that's interesting to note. And then the other thing is, because we've got an energy-only market, the only way that the market operator can encourage participation is by the price. And so clearly, if the price dwindles away, batteries will no longer provide the service because the value isn't there. They can get more value in other markets. And so what you'll end up with is the market will return to an equilibrium price that batteries can actually tolerate. And against the common myth again, battery operators, in my opinion, are out there to make money. They're not altruistic folk who want to drive the energy prices into the ground and leave it there. That's not the business that they actually operate in. Batteries cost money in capital to build and also to operate, and that money needs to be recouped in the market. So those would be my comments on the future of FCAS pricing and the reasoning behind it. So I just wanted to summarize a couple of key takeaways, and hopefully I'll have left enough time for questions afterwards. So hopefully I've got across in that slide deck that the FCAS market is very different to what a lot of people picture as traditional demand response. And hopefully people are reevaluating their opinions that way. FCAS is highly lucrative and accessible to industrial and large commercial customers. There's no doubt about that. Again, in my opinion, the prices in the faster FCAS markets are likely to remain high, and it's due to restricted supply and high demand levels. Economics takes over, and the price there should stay relatively high going forward. The FCAS or contingency FCAS markets, and particularly now with the R1S come in, it involves only very short and infrequent disruptions that oftentimes can actually be managed on site without any significant plant disruption at all. And like I said, aggregators like ourselves, VIOTAS, we're used to doing the engineering involved to get in on site and understand how the plant actually operates and what loads can and can't participate accordingly. I've shown that demand response sites actually delivered a significant portion of the new R1S volume in the last quarter, as in last year. That doesn't get talked about a whole lot. I don't know, the news seems to talk about batteries for whatever reason a lot, but demand response is right in there at an equivalent level. And finally, the demand response participating in FCAS, it is well proven. It's been around for many years now. And any market risks for the customer in participating, those sit with the aggregator. Just to be clear on that, that's not a risk that the customer site themselves wears. So that's it from me. Jared, I'll leave it open to questions.
Brilliant. Thank you so much, Paul. And we've got some questions coming in, and we'll certainly get to those. My first reflection is this R1S market, 1 second off and then back in 6 seconds. I wish this was available when we did a bunch of research, and I could have asked a lot. We interviewed like 30 or 40 industrial users 20 years ago, and sorry, 20 years ago, 4 years ago. This would have been quite interesting to ask them. I think that we would have got a lot of different responses there if it's only 1 second or for 6 seconds. Brendan, game changer for chillers as well, this R1S market. Surely this is opening up a lot of opportunity.
Sure. And this encourages people possibly to look increase a bit of system reliability by adding some water storage to handle those events as well. So there's a positive flow onto design, but also people have always looked to make money out of their chilled water plant. And frankly, with the old systems, it was quite difficult. So I think this makes life a little bit simpler, which is nice. You can see some people willing to go down that road because, yeah, it's a load that can be shifted quite easily and not impact much unless it's really, really hot outside or really, really cold, one way or another, for heat pumps, for example. So,
and a question for you, Paul. I'll ask one. I'll get Brenda to take some more after that, because I've got one as well on this. You said the 500 kilowatts. You mentioned that as a sort of a minimum load there. Does that need to be in one location, or can it be distributed in different locations? I was more wondering, does it have to be one single motor, one single drive, or just can you just unpack that a little bit for us?
Yeah, good question. So it would be one controllable asset, or we call them controllable units, but one single asset that we can control. Now, I should qualify that by saying there are, once we get into the engineering, and this isn't the right forum for it, but you can oftentimes find that you can control multiple individual assets from a single control point. And so as long in that case as the total is greater than that, we've got a single control point that we're managing, and we can capture multiple. That's not universal. You've got to go into a site and look at the the electrical drawings and have a look around, see how everything's actually connected. So take it as a rule of thumb. That's what it's intended as. Okay,
but in which case I'm thinking about a lot of meat processing plants and refrigeration plants. They're looking at a series of probably 200 kilowatt drives on their compressors. Are you saying if you can control all of them at one go, that's okay?
Yeah, so hopefully the conditions are right and there's a PLC somewhere that's controlling each of them, and we can work with the PLC guys to modify the code slightly and capture multiples. It comes a cropper generally in older plant where that level of centralized control and monitoring may not actually be there, and it becomes trickier, and then you have to put multiple meters in, and then the business case starts to fall apart a little bit.
Gotcha. Thank you. A few more questions coming through there, Brendan.
Cool. I'm going to pick the one that says that's most interesting, or we'll take hopefully the most interesting is how do those with solar systems participate? Like, how does having a solar system on site, does that change anything for participation?
Yeah, good question, Brendan. And yes, it does. So clearly solar will mask load at a site. So if we're talking about the raise services, solar at a site actually reduces the capacity to respond to the raise market. But the interesting thing that we're looking at the moment is whether or not it's possible to actually put the solar itself into the lower markets to compensate for the masked revenue. So if you consider what's driving the lower price, and the lower prices are increasing in South Australia and Queensland, particularly where you've got large amounts of rooftop solar. In a roundabout way, that drives the lower market value during the solar hours. And so a solar farm that's online could actually get access to the lower services if they were willing to drop the solar. And so that's something that we're looking at. And so then you can offset the lost revenue during the solar hours by picked up revenue in the lower markets. So that's entirely possible.
Yeah, and I think I'm following on from that again, just on the subject of, I guess, participation. Are there certain retailers, or are we just independent from any retailer for this type of?
As in, so FCAS is separate to the retail contract. So if someone's with a retailer, there's no issues in dealing with an aggregator outside of that. Obviously, I should put the proviso in there, assuming the retailer hasn't got the customer tied into an FCAS program. If they're not tied into an FCAS program, there's no reason not to. The only things that need to be considered is, and Jasper was alluding to this earlier, if the site through the retail contract is participating in, say, wholesale energy markets where they're likely to be potentially out of the market for a period, that impacts availability for FCAS as well. So those sorts of things need to be factored into the business case if that's the case. But if it's a standard common garden retail contract, yeah, you can go for FCAS through an aggregator.
And
cool.
Jasper's typing away. Thank you, Jasper. We'll get a bit
question,
short
yeah.
on time. I'll pop your Jasper's answers. We'll put that in the slide deck when you get that distributed. You'll see them there as well. But thanks for that, Jasper. Brendan, probably got time. Let's squeeze in one or two more questions.
Sure. Onto some application type questions. There is a question here about what are the requirements for the metering for the to pick up the frequency drop, and I think we kind of answered a little bit indirectly where we put it, but yeah, just expanding a little bit more on what's required in the metering.
Yeah, so there's a for the techies amongst the group, there is the MAS document, which is the ancillary services specification, which has a whole chapter around the metering requirements. If anyone cares to go and have a read to that, I'll happily share it as well. It talks about the resolution of data required for compliance reporting and also for event monitoring and so forth. In addition to that, so what companies like, VIOTAS, my own company, does is we have optimized algorithms as well to decouple transient events from actual real grid events. So it's more than just a standard off-the-shelf meter, and it's very tightly integrated with our bidding and bid optimization platform as well. So our approach is to use an integrated bid engine down to the site metering level, because that helps us to get the speed of response rather than using a third-party meter and then you've got metering interfaces or cloud-to-cloud comms in the middle. We found that a fully integrated package gives the best response from our perspective. And then in terms of the best location, so the obligation is at the NIMI. So the metering for compliance has to be at the NIMI. You have to see a net change in demand at the gate, so to speak. But we will oftentimes also put meters in at the subboard level to monitor the CPUs as well, or sorry, CPU, CU, the controllable units, individually, so that we can get better forecastability of those to help with the bid optimization piece that I talked about. So that's not a requirement, but it's something that we do because it gives better market participation.
Thank you. More of a comment than a question here. We see that NLX is on the line today and saying that's the other major FCAS provider, and they can go down to 10 to 20 kilowatts per site. So just another option there for people, for those with the smaller loads there. We're a bit over time, but let's squeeze in one more, Brendan.
I think the question to answer is the role on community batteries in different FCAS markets, because that's the most, I think, out of the other ones, I think we can type answers to. So that's the one we can't type an answer to in enough time. So it says, yeah, just your point of view, Paul, on what role community batteries can play in the different markets.
Can we separate the technical side from the rest? I think technically there's no reason why a community battery wouldn't participate in FCAS, and I think they should. I think it's beneficial for the broader community to do that. How community batteries are set up commercially and ownership wise, that's a whole different discussion, and I think we'd need a whole separate webinar to get into that. I'd prefer not to share my opinions on that one. We can share a beer someday and I'll tell you what I really think about the way it's currently been done.
Ooh.
There's a lot of potential in community batteries if it were to be implemented properly, I think.
To round out a super simple one, just to clarify the number of events, was it 6 to 12 events for all 8 markets together, or just in one? It was one of the questions, very easy to answer, I think. So.
Yeah, pretty easy to answer. So 6 to 12 on average. Bear in mind we are dealing with averages here, so it's a bit of a range. All 4 markets. So the way it works is it depends on the event duration. So you bid into all 4 markets, but depending on how long the grid event lasts for example, if you were bid into the R5 market, you actually don't start responding for 5 minutes. The grid event could have been over by then, so you're not necessarily responding if you've bid R5. But theoretically and interestingly, the timing, the event on the 13th of February did last for 9 minutes. So if you were in all four markets, you would have responded across all four in that case.
Brilliant. Excellent, thank you. And a good way to finish there rather than the can of worms for the second last question. That's very good. Paul, Jasper, Brendan, thank you so much for your contributions today. As I said, we'll get those responses from Jasper, typed out some brilliant responses, some of those questions. If you didn't catch those, we'll put them into the slides and you'll be able to see them there. Otherwise, yeah, both of you, thank you so much for your presentations today and the insights. Really much appreciated. So just to finish off with now, let you know what's upcoming with A2EP. Our work we've done with aquatic centres and councils is coming to an end. Just a couple of more little network meetings to try and help councils with their submissions for that $50 million of funding that's coming up in round one, closing at the end of April. And then coming up in a week or so's time, we have Dr. Gordon Arbogast. He is world famous for high temperature heat pumps. He has been updating his research on what's happening in terms of steam heat pumps and these ultra high temperatures. It is absolutely one not to be missed. It is our most frequented webinar that we do each year, and you'll really get a good feel for what's happening in that market. So please join us for that one. And of course, as always, register at a2ep.org.au under the events section. That's about all we have for you today. If you want more A2EP, you can follow us on LinkedIn and subscribe to our e-news. You'll get all of our insights straight into your inbox. So that's it for us today. Thank you so much for joining. We hope you have a very pleasant afternoon, and we look forward to seeing you at our next webinar or event. Thank you and goodbye.